Ray tracing. Ray tracing is an advanced rendering technique used in computer graphics to create highly realistic images and simulate the interaction of light with objects in a virtual environment. It is based on a complex mathematical model that accurately replicates the behavior of light rays as they propagate through a 3D scene. This method is in contrast to traditional rasterization, which focuses on rendering individual pixels and may sacrifice some degree of realism. Here's how ray tracing works. Ray generation. The process begins with a virtual camera or eye from which rays are cast into the scene. Each pixel on the camera's image plane corresponds to one of these rays. These rays are sent into the scene to simulate the path of light as it travels. Ray-object intersection. As these rays traverse the scene, they may intersect with objects. To determine these intersections, mathematical equations representing the rays are compared with the geometric descriptions of objects in the 3D environment. The point of intersection and other relevant information, like surface normals, are recorded. Surface properties. Once a ray hits an object, its properties are considered. The material properties of the object, such as its color, texture, transparency, and reflectivity, are used to calculate how the light interacts with the surface. This includes handling aspects like diffuse reflection, specular reflection, and refraction. Secondary rays. In addition to the primary rays from the camera, secondary rays may be generated based on the surface properties. For instance, if a ray hits a reflective surface, a new ray is created to simulate the reflected light direction. Similarly, for transparent materials, a refracted ray is generated to simulate the change in the direction of light. Shadows and light paths. Ray tracing also takes into account shadows. To determine whether a point in the scene is in shadow or not, rays are cast from the point to light sources. If a shadow ray intersects with any objects before reaching the light source, that point is in shadow. This allows for the calculation of both direct and indirect illumination. Recursive process. The above steps can be repeated recursively, allowing for complex lighting interactions such as global illumination. This means that the behavior of light is not only calculated for the primary rays, but also for rays generated from secondary interactions and so on. Image formation. Finally, the information gathered from the rays is used to calculate the color of each pixel on the camera's image plane. This results in a highly realistic image with accurate lighting, reflections, shadows, and surface appearances. Ray tracing is known for its ability to produce photorealistic images and is widely used in applications such as video games, movies, architectural visualization, and design simulations. However, it is computationally intensive, and real-time ray tracing has only recently become more feasible due to advancements in hardware and software, making it a technology that continues to push the boundaries of visual realism in the digital world. Thanks for watching. For more videos, please like and subscribe.